So welcome. Sorry, we had a few technical difficulties here, but welcome to Lightning Security Best Practices. I hope you've been enjoying more technical difficulties.
All right.
Next. I hope you've been enjoying Trailhead X so far. I know there's been a lot of cool stuff. The keynote blew me away personally, and I've worked on some of those things. But if you don't know us, we're the security team. We have a booth over near kind of the Einstein area in the general Salesforce discovery zone. But I'm Ryan, and this is Lihan, and we're on the product security team. That means we do a lot. We both secure the products and services you use that Salesforce provides. Myself, I'm Sales Cloud and Einstein. Lihan, your Service
Cloud.
And we also work on the App Exchange. So those of you who are ISVs, or those of you who are just building little components to make your own org run a little better, we're the experts in that. And if you've done an ISV and published your package on the App Exchange, you've gone through a security review. And here's two reviewers. We're the people who actually went through your app, looked and remediated, helped you remediate any results. Before we go on, though, there will be a few forward-looking statements we make. Salesforce is a publicly traded company. If you are going to make any purchasing decisions as a result of this talk, only make those decisions based on what is currently available and not the content of this talk that has not been released yet. But let's talk about what we're going to talk about. First, we're going to do a quick overview of Lightning. I hope most of you are pretty familiar with the Lightning framework. Given that this is security, we don't have time to walk you through the basics of development and the general life cycle of it. But we're going to talk about what we care about for security, how it's different than both standard web development, such as most of you learned, or even the Apex Visual Force platform that we all know and love. And there's a few things of that. We have encapsulation. We talk a bit about the Aura lifecycle and how to respect it properly so your app functions well. Any JavaScript we use and how we want to use that safely. A little bit on CRUD FLS. I hope you got to see the CRUD and FLS talk we had earlier today. And then, honestly, I think the most important thing we can do here is to answer your questions. So we're going to get to that. But before we go on, Lihan, what's Lightning?
Thanks, Ryan. So before we dive into the details about talking about security of Lightning, we'll give a quick overview of what exactly Lightning entails in the context of our presentation here, and give you an idea of what you can work with when we talk about Lightning. So there are four major pieces of Lightning. First thing we're going to talk about is the Lightning experience. So I'm sure all of you have already tried out the new Lightning experience we have in Salesforce. It's really cool, one-page experience, unified UI, everything looks the same. And the best part about it, which kind of leads straight into the Lightning components framework, is that it provides you guys, the developers, a unified development experience. You can have one set of code with very minimal adjustments that will work very well across all the different platforms, so on your desktop, on your browser, on your mobile browser, and in Salesforce One. So the Lightning Components framework is a new JavaScript development framework that is based on the open source Aura framework that allows us to have a reusable and shareable components that you can develop and put anywhere on the app, and it will look great. So we may interchange the terms Aura and Lightning here. In this context, they're effectively the same thing. However, just if you're interested in knowing, Aura is the open source framework, and Lightning is specifically tailored for Salesforce. We also have visual building tools. So that's a drag and drop thing. You may be familiar in the classic Aloha UI. So it allows you to, you'll see later that with components, it's really easy to modularize the different things that you want to display on your page. So you can easily use the drag and drop tools to search for components. I want to show a graph here. I want to put it on the right side or left side for you guys, the sidebars and things like that. Lastly, we have the Lightning design system. So this is a collection of style guides and UI, CSS rules that follows the best modern UX practices. And best of all, it allows your components to, with minimal work, look exactly like how Salesforce looks like. So I mentioned the word component probably many times already. You guys are probably wondering what exactly is a component. Well, components are building blocks of Lightning. So it's kind of like individual Lego pieces that you have when you build an entire set. So you see here, this is our sales homepage. There are a lot of different components. Each of the red box is one component. They're self-contained, and they're integrated into the UI. Pages and apps, even internal pages and apps, are built with a collection of components that work together. So you can see in sales, it makes a lot of sense that you have the quarterly performance view, you have upcoming events that you may want to know, you have reminders on the right side that you can have to just kind of work together on what you want to see as a user in the sales application. Well, you build different components and you support each other. Before we jump into the specifics of Lightning security, we'll talk a little bit about Visualforce, the difference between Visualforce and Lightning in technical detail. So how does the lifecycle work on the browser, on the server side? How do they interact with each other? And what is the difference? And I'll give you a little bit of context on why in Lightning we have different kind of security considerations. So we have our well-known Visualforce. So the process is pretty simple. The user goes and requests a page like /apex/mypage.apex page. The server will parse your Apex code and then return HTML. The browser displays the page to you, and then you as user interact with the page. You fill out a form, you click some buttons, and it'll go back to the server, and then the process repeats. So this is great because it's a well-proven model. It's very easy to understand, very easy to create. Easy to implement. So it naturally splits very large apps into different sections that you can split up with pages. And it has built-in metadata integration, so it means that it works. Visualforce and Apex are tightly integrated. There's a lot of things that you don't have to. For example, if you want to display data, it even performs some credit for you. However, there's limited interactivity. So you may have tried to visit an Apex or Visualforce page on your mobile browser. It doesn't look very good. And also, there's a high latency because every time you request something, it's a round page to the server, and you have to sometimes, like headers, footers, they're information that you already have on the browser that has to get sent back every single time. Well, Visualforce evolved to become an application container, and it closely follows how Lightning works. So basically, you request a Visualforce page, and it contains a JavaScript library. What the library does, so you get the browser on the per browser. What the library does is it loads the actual application, and it talks to the server. You make asynchronous calls to the server that gets the data you need onto the page, and then the JavaScript library parses the application, and you see it on your browser. Instead of refreshing the entire page, JavaScript will only grab the data that you need and refresh page things that you need to see refreshed, updated. Well, this is good because it's a lot more interactive than Visualforce. However, it's more complex to build. It's not exactly a built-in experience that we have, so you have limited metadata integration. And the development experience is not great. So now we introduce Lightning components, so the Lightning framework. Again, it begins with you requesting a page. This time you request an app or a component. So the component bundle is returned. The browser loads the bundle. So this is all very similar to the application container in Visualforce. JavaScript generates a UI. And again, you interact with the page, and you only retrieve information that you need. If I do a search on my account search page, it will only return the component with the new account data. It doesn't have to refresh the whole page. Well, this is awesome because, again, this is very immersive and highly interactive. It aligns well with the Salesforce UI, and it's really integrated into the container. Also, again, this now has metadata integration with Salesforce, and it provides a great experience for developers. We provide a lot of tools that I mentioned already to help you build Lightning components. Well, with all of that, so why are there new security considerations? Well, quoting the great Uncle Ben, or paraphrasing, more power means more responsibility. That's a responsibility on you guys, on the developers, to respect these three things that we're going to talk about. So you want to consider how your components are sharing the DOM. So DOM, you're sharing the page with other components. And that's just not just other components that you made yourself. They're also components that is default in Salesforce or maybe even developed by another developer. You want to respect the Aura, the Lightning lifecycle. The JavaScript frameworks have a very specific way of rendering components. It's different from what the usual classic model of requesting an HTML page. So you have to respect the lifecycle for your components to behave as expected. And lastly, a classic security issue in front-end JavaScript development is don't trust user input on JavaScript. Unsafe JavaScript calls could break your component. We have limitations that allows what you can or cannot do, which we have a demo that Ryan will show later. All right, so jumping in. The first thing we're going to talk about in detail is Lightning components. So we're going to revisit this page again. Again, components share the DOM. Each of the boxes are components. So you may not be aware of this, but your components can be placed anywhere you want. Like I talked about the dragging and dropping thing. So you can come here and edit. You want to take your recent records or the components you develop and drag it and put it here. Well, if that's the case, you don't want it to overlap with anything. So that's why encapsulation is important. Everything inside your component needs to stay within its box. So that includes visual CSS. You don't want your boxes to, we'll talk about CSS roles in the next slide, but you don't want your boxes to overlap each other. And in terms of the DOM, in terms of elements, you only want to modify things that are inside your components. So one thing I would like to note, like this is so important because your application may be secure, but if your org, let's say you develop components for your own org that's not published, you develop an application and your components are great, they're perfect, they follow every security rule. However, you install another package from somewhere else or somebody else develop components, they're going to interact, the components can interact with each other in ways you don't expect. So even if you've done a great job of respecting Lightning security, the other components may not. This is why this is important. So component encapsulation. I'd like to mention that Locker servers is now on by default, and it helps with component encapsulation. We're only going to talk a little bit about Lightning Locker servers here. But if you've gone through the app exchange process, you know that we still enforce things that Locker servers are supposed to do. Well, why is that? It's because we have some customers that don't have Locker servers rolled out yet. And to be fair for everyone, we want to make everything secure for the lowest common denominator. So all the applications currently that are developed and published for App Exchange, we enforce Locker security. So that's about Locker service. You don't want to use global DOM access methods like getElementById because since you share the DOM, you can have a component on the left that says ID is graph. And then you have another component that also has the ID named graph. Well, when you do a getElementById, which one does it return? You don't necessarily know. And so that includes CSS. We want to make sure your CSS is within the box. Lastly, when you're using third-party libraries, which is inevitable, you don't want to reinvent the wheel if you want to use graph. If you want to use maps, you may want to use leaflet. So be aware of which libraries you're using with your components. Most of the modern popular libraries do work with Lightning. We have a link later on that will show you the libraries that are currently supported. Basically, if they follow strict JavaScript and best practices, you should be okay to use. However, if you want to use things like Angular, those like other JavaScript frameworks that would interrupt and just kind of really mess up how Lightning works, you may want to use this thing called Lightning Container Components. So it's basically a convenience tool. It provides you an iframe and then with an API that the iframe can communicate with your component. Okay, last thing about component encapsulation. Just some quick examples here. You want to use the framework provided methods to do your DOM manipulation and retrieving and setting of components. So do component.find. Try not to use document.getElementById, or if you're using jQuery selectors. Again, this selects the entire DOM, and it could select another component that you have no control over. Lastly, CSS. We have a set of rules for CSS that you can check out on the Lightning developer force page, and it tells you which CSS directives you shouldn't use. So remember to respect other components. Okay, we're going to jump in to talk about Aura lifecycle, and Ryan will take over here.
Thanks, Lihan. In my opinion, I love a lot about Lightning. I love a lot about our Lightning platform. But the Aura lifecycle and how Aura actually manages everything is probably my favorite part. If we remember we probably should have put this slide in there again, but if we remember back to our Sales Cloud homepage where we have the little graph and the opportunities that are either 30 days with no activity or overdue. How do we make sure that all of those are painted to the DOM correctly? And if I get a new opportunity, it gets inserted here without having to repaint all of this and redraw all of our top deals. Well, the order lifecycle determines a lot about how that actually works, and there's a lot of weird stuff under the hood. And it's really cool, but it's a little opinionated, and we will actually want to make sure that any Lightning component in our Aura lifecycle respects the way that Aura does its job. Now, we publish a lot of ways to do it, but on the App Exchange, for example, we actually strictly enforce it. If you're writing code for your own org, you can probably get away with it. You may see some quality issues down the line. But on the App Exchange, since you don't know where you're going, we have to enforce that everyone's up to the same level of quality. And there are a few ways to do that. LTNG require. Most of you have probably seen this. It's how you should load static resources into your components. How you bring in your JavaScripts, your CSS. That just makes sure that everything's wired up correctly, and it actually does a little caching for you, so we don't load the same jQuery library 9 different times. We don't want to modify the document directly. And there's a few reasons for this. The most obvious is you don't know when you're getting re-rendered. You don't know when the component next to you or above you needs to change something, and whether that change actually impacts your component. If you modify the DOM directly, the Aura lifecycle might not have the ability to see that change, unless you initiated it through the component initialization or a renderer. What we prefer that you use is just, when you're displaying the data to the user, store that in standard Aura attributes, and have those Aura attributes be the data display for the user, and they will get updated automatically rather than modifying the DOM. But that's great for just flat apps that don't do anything. But Lightning's fast, Lightning's responsive, but we want to respond to something. We have to respond to events. Now, we also want to make sure that all our events also flow through our Aura lifecycle. And this is pretty easy. Those of you who've worked with it, you know when you're creating a button, it's just as simple as doing onClick equals, then the Lightning interpolation tags, curly brace, exclamation point, C dot, whatever handling method. Pretty straightforward. For other stuff, such as asynchronous JavaScript, you also need to declare that to the Aura framework, just so that we know if your component's gone, we don't want to pop up your session timeout window. So do that with a $a.getCallback. And actually, this also helps wrap you in our encapsulation that we've seen. So we talk about encapsulation, making sure your component stays in its component, and no one else messes with you. You wouldn't want someone else to pop up an alert box, but even though their component's gone. So we want you to play fair and practice defensive components. Practice defensive components. So let's go to the next slide here, and just quick examples of what I've talked about. Pretty straightforward. I don't think I have to go too deep into this. So if we want to go to the next slide again. Great. JavaScript is such a powerful language, or it includes a lot of JavaScript, but let's see what happens. Turns out JavaScript is still JavaScript. All the same JavaScript rules we had for Apex Visual Force, we also have here. Anything you could do vulnerable in JavaScript before is also here. Don't execute or evaluate user data as code. You don't know what that user data is. You don't know what code that will run. That's your classic eval. We have the shared access to the DOM. Again, that just makes everything a little bit more dangerous. So if my component's safe, or unsafe, sorry, I can hurt Lihan, and I don't want to hurt Lihan. Additionally, since everyone's on the same DOM, any stored secrets client side could be put next to an unsafe component. So any secrets should try and live server side where they're safe within your namespace. And here we see we don't want you to use any evaluation functions. And if for some reason you do need to do that, take extra care to sanitize and to whitelist what input you can. And let's actually go on to our demo here.
I want to point out that we also shouldn't overwrite what functions mean. So I don't. Yeah, is that here? Yeah. So if you don't want to overwrite, like let's say, eval to something else, we actually don't allow that.
Yeah.
So we have a
Again,
demo.
we're in a shared playground. Other people expect functions to work the way that the lifecycle defines them. Modifying the window functions isn't great. So let's jump over to Firefox here. Here we have our wonderful little home page. And here's just a small little Aura app I wrote. We have our welcome to the Lightning Security Basics, and we have a button. So let's take a look at this. Cool. And this just, all it does is it evals alert for this message for hello Trailhead X. So if we do that, you'll see we actually tried to protect you here and removed eval. We do this through two ways, both through locker service and through content security policy. However, content security policy doesn't apply to all browsers. Safari and Internet Explorer don't respect it at all. So we try to enforce it at the locker level. But what did we just talk about earlier? Does everyone have locker? If your own org has locker, you're probably fine. But like we said, there are some customers who just can't make that jump yet. So we want to be safe for them. So you'll see that despite our best efforts, we can't eval. But we can accomplish that same functionality a different way. Let's get back to presenting. Great. So, CRUD and FLS. Just for my own record, who actually went to the CRUD and FLS talk today? Oh, I see a few hands. That's awesome. Well, Lehan, if you want to go to the next slide, most of this you probably already know. CRUD FLS is not checked by default in Apex. It runs in system mode. You're writing code. Code should have access to all the data it has access to. It's up to you to determine what the user has access to. Visualforce pages will do that for you on the client side. Lightning components provide no such guarantee. Additionally, you don't want to provide these checks client side. Because what did we say about storing secrets client side? If the data makes it to the client, there's a way for malicious components to get it. We also have a beta feature we call Lightning Data Service. This is for your kind of controller-less code. It will automatically load the records for you, do the CRUD, FLS, and sharing restrictions for you, and handle it all, but you lose some of the ability of writing your own controllers. And I hope you saw our talk. I'm sure the slides will be available after the fact, but let's just move on. Now, I saw a few of you taking pictures before. I want all of you to take a picture now. These are all the resources we have. Pretty much everything we spoke about is pulled from these and is done in way more detail here. And I really encourage you to go to these links, read it, ask some questions on our partner forum. And I would really like to promote our secure Lightning trailhead. That is brand new. We just released security for Lightning components this month, actually. We've been talking about it for a while. It just came out. And if you've already taken it, come talk to me. I'd love to hear any feedback you have on that. But frankly, I'm done talking. I think, Lehan, your voice is kind of tired too. Let's ask you guys for questions. If you have anything, you can try and come up to the mic here or shout it out, and I'll try and make sure everyone hears it. Yeah. So, yeah, you're worried about kind of Lightning performance if we have a little too many components. And that can be a valid complaint if you overflow it with components. We do offer you the ability to write what's called an Aura app, or Aura application, which actually owns the top level. So, just like when we log into Salesforce, we get the great big homepage. If you look at the URL, you'll see /1/1.app up there. That's actually an Aura application. We allow you to write your own application, which controls everything below it. So if you're worried about performance, you can control the whole page and actually make sure that no one's overloading your app with too much extra stuff that's going to slow it down. Anything else? Or did that answer your question? Great. Well, if anyone has any questions they want to take offline and don't want to bring to the table here, we'll be standing over there for a few more minutes. I would encourage you to come visit us at our booth over by kind of the Einstein stuff in the product areas. And I've been Ryan. That's Lehan. Thank you so much for coming to our talk.
Thank you.